Hello everyone and welcome to today's lecture. Today we're going to be talking about malware and social engineering. So a couple of lectures ago we went through kind of the big picture malware. We talked about some statistics and some trends in the industry and just with general consumers, as well as looked at Zeus and CryptoLocker and some point of sale malware. So if you haven't watched that lecture yet, I encourage you to go back and take a look at that, especially to get a better insight into how some of the very popular or prevalent malware operates and behaves. Today we're just going to spend a few minutes and really just talk about some terms, definitions, and categories. Okay, so setting more of a baseline so that you understand, being in the industry and working in this field, what everybody's talking about. So first we'll start off with defining what malware is. Malware is simply malicious software. And when we talk about malicious software, then the term malicious, while usually you think something bad, like Zeus, it's stealing credentials so that someone can steal your money. That's very malicious. Or CryptoLocker, a virus, it's a piece of malware that tries to encrypt the contents on your computer and hold them ransom. That again, that's very malicious. But it can also be just simply unwanted behavior, such as a piece of malware that once it's infected you, it has a pop-up screen and maybe it shows a graphic image or a really silly political message or just something that you don't want. Okay, so if you look at the definition here, it's software. Okay, it's a program. It's a program like anything else. There's really nothing special about it other than it does things you don't want it to. It does things it doesn't advertise, or it does things that you just aren't expecting because you don't know that it's on your computer. But it's still a program. So somebody says sit down and write it like you do any other piece of software. It enters the computer system usually without the user's knowledge or consent. Right? Consent's probably the big one. Knowledge can be arguable because oftentimes most people infect themselves. They just don't realize it. They click on some attachment in an email and they didn't realize that was actually malware and not a PDF that they thought it was. So they're unaware, although they're oftentimes the trigger to get it to install. It then performs an unwanted and usually harmful action. Okay, the next 3 slides we're going to talk about malware categories. And this is by no means how malware is actually classified by antivirus vendors or malware analysts. This is just a way for us to break malware up and look at some of the characteristics or behaviors it exhibits. With that, keep in mind that malware often will have a lot of these characteristics in one piece of malware. Zeus, for example, could be considered, now it's not really a virus, but some of the later categories that we'll talk about, rootkit, backdoors, even logic bombs in a way, that can be Zeus. Okay, it can have a lot of these characteristics in one piece of malware. Oftentimes, if you look at malware, you'll hear things such as family and variants. Families then typically are how they're classified, and that is, banking Trojans is a family. And so it's malware that all exhibits characteristics whose ultimate goal is to steal financial information. The Zeus family, a variant of Zeus then would be a piece of malware that exhibits behaviors very similar to those original or core versions of Zeus, but maybe does something a little bit different. Okay, in that previous lecture we talked about Game Over, and Game Over Zeus is a variant because it uses peer-to-peer technology to communicate instead of communicating directly back to a command and control server. So that's a little bit more standard on how antivirus vendors and malware analysts classify that information. So if you do research on malware, you'll probably see that terminology more. So to start off with, virus is often kind of that default term that if people don't understand malware, everything is just a virus to them. And so let's look at virus and really define what it is so that we can better understand how malware works. Well, a virus is simply a program that attempts to replicate itself on a single machine. Okay, how you get the virus, it may come in through USB, it may come in through an email attachment, but once it's on the system, once the user has executed that virus, then it only infects that machine. Now, viruses will try to copy themselves to other files, and that means that once you get infected with a virus, you can have multiple locations, multiple files infected on that system. So sometimes they can be very hard, if not impossible, to remove. the virus still depends on the user to execute it. And there's several types, but there's three kind of common ones. One is program, okay, and that is a virus that infects other programs. And programs in this case are EXEs or executables, and that's just other programs. So if it infects other programs, then when those programs run, the hope is that then that is infected with that virus, and it can infect other programs. There's the macro, and that's usually found in Office products. So you can write macros in Word and Excel, and those macros are like little programming languages, and they will execute, they will do something. And so malware or virus authors can exploit that. That's why when you download Word docs now from the internet and you go to open it, it'll give you some sort of a safety message that says, we've disabled a lot of functionality because this file came from an untrusted source. Do you really want to enable it? And you click enable it. Now you'll have macros and all that other stuff. So, Microsoft and other Office vendors have tried to keep up with preventing that type of virus. There's boot viruses, and those typically, those infect the MBR. That's the master boot record, and these are pretty rare. So just know they exist, but we won't really spend any time on them. Before I move on, though, what a virus and what a lot of malware will do, there's kind of two things it needs to do. One is to deliver its payload, and then the other is to replicate or hide or set itself up to be persistent. So in the case of a virus, its two things will be to deliver the payload and then try to copy itself into other, whatever it's targeting programs. The payload then is just what is the purpose of the virus itself? What is the purpose of the program? If it's to pop a message, if it's to encrypt your content, if it's to run silently in the background and try to steal your username and password credentials you type into websites, doesn't matter. Whatever that payload is, that's the purpose of the program. It'll try to deliver that, to do that, and then copy itself off. All right, so that's viruses. Worms, then, same thing. It's malicious software. It's a malicious program. The difference between the virus and the worm is that worms will try to spread to other computers on its own. Okay, so worms are self-propagating. Viruses are not. Viruses can still spread. I can still put it on an email attachment and send it to you. I can still put it on a USB drive and have you open it and double click it. But worms try to do it on their own. And oftentimes they'll do that over the internet, over the network, enumerating on the machines, finding vulnerabilities, and then trying to exploit those and move itself around. So once it does that, okay, it's going to execute its payload and then try to move around. All right, there's malware that hides. So a couple of different categories here: Trojans, rootkits, logic bombs, backdoors. Trojans, those are often going to come in the form of a program that advertises some sort of functionality, but then also offers a backdoor or does something unintended. So it wasn't that long ago, maybe it's been longer than I think, a few months, maybe a year, but the brightest flashlight app, okay, is actually a pretty common or popular app in the Play Store. And it ended up being, I think it was a Trojan. I guess I'm doubting myself a little bit on that. But its purpose, all it said it was there to do, was to be a flashlight, to turn the LED on your camera. But behind the scenes, it was doing a lot of other things. And I think it was just stealing general information about location and other things. But now I don't remember now. So this is turning out to not be a great example. I won't go into any great detail with any of these categories. I won't, give you guys a bunch of examples. If you purchase the Security Plus book, there's some examples in there. If you didn't, you can certainly search for any one of these topics and get plenty of examples, especially something that's relevant and recent. So I'll leave that up to you. It's not necessarily important for the labs or the quizzes or anything, but it is worthwhile if you have some time to look into some of these different categories. So that's a Trojan. Think back to it all started, the use of the word Trojan comes from the Troy War, and where the Greeks delivered a big wooden horse to Troy, and inside of it they had a bunch of their troops, and they got it behind the gate. Once the sun went down, then they opened the gate, they came out, and they killed the defenders of the city of Troy, and then eventually took the city. So that's what it is. So if you forget, just think back to that story, and that'll help jog your memory, hopefully. Rootkits, the next category, and rootkits are tools that are software that's employed by an attacker to hide the actions or presence of another piece of malicious software. Okay, so oftentimes rootkits are used in conjunction with Trojans, viruses, and worms, and that is that they try to hide the activity. They clear log files. They make it so that um, when you're looking in a specific directory for a an application or program that doesn't belong there, it can hide it so that the Explorer window doesn't show that to you. Um, it can, if you open up your task manager in Windows and look at the different processes, it can hide that process so that you can't see it. There's other ways to detect it, but the whole purpose of a rootkit is just to hide its presence. Okay, just to hide the presence of the malware so you don't know it's there, so you can't detect it, so that your antivirus can't detect it. Logic bombs are next, and these are code that usually it's malicious code oftentimes that lie dormant. They lie in wait somewhere until a specific time kicks off. So they've been installed on a system, they're running, they're checking the clock, they're running as a service, however they're set up, but they're actively waiting until a certain time elapses or a certain date occurs, and then they trigger their payload. That payload could be, you name it. Oftentimes you hear stories about employees that have logic bombs ready to go, for if they get terminated. And then if they get terminated, they have just enough time to set off their logic bomb, and 30 days later it tries to delete everything from from the database servers, or do damage to that employer. The last category then is going to be our backdoors. And backdoors kind of come in two flavors. One is the the intent that or the bad guy has, excuse me here one second. Okay, I apologize for the little interruption there. So backdoors then are, so they kind of come in two different ways. One is that somebody, an attacker has exploited a system, and he or she has installed a program that allows them to access that system later on. So they've exploited it, and then they're allowing themselves to maintain access. And we'll go through that here in the later half of the semester when we look at exploiting servers and kind of the network side of hacking and penetration testing. Another one would be in the program itself, and oftentimes programmers leave backdoors in their own code. It's not malicious intent, but they do it just to facilitate their access or the ability to update the software or something else. The whole purpose of the backdoor is, though, that it bypasses normal security and access controls. Okay, so anything that bypasses that is going to be considered a backdoor. If I leave a backdoor in a system and I can just log into that backdoor, log into that system through the backdoor, that's subverting or circumventing the normal access controls, the normal way of logging into that system. Same with an application, same with the service. Doesn't matter what it is, as long as it's circumventing that process. All right, the final category that we'll talk about, malware that profits. We can look at botnets, adware, and keyloggers. So botnets aren't necessarily a specific piece of malware. Nobody really writes malware that is just a botnet. Malware, though, can become part of a botnet. So Zeus, again, is a pretty good example in that I will decide, let's say I decide to become a bad guy and I want to create my own botnet. So I'll create my own version of Zeus, or I'll hire someone to do it, or I'll purchase it in the criminal underground, and then I'll somehow get a lot of computers infected. So if I send it out, maybe I do a phishing campaign. We'll talk about that in a minute, and I attach that Trojan to that email, and I send it to 10,000 people, and 2,000 people actually click it and infect themselves with that Trojan. Now, because I've set that Trojan up to all communicate back to me, to wait for me for commands, they are essentially under the control of my botnet. Botnets are being used for a lot of different things. They're being used to mine bitcoins even. And was that malicious? I mean, maybe not in the sense that they're stealing data from you, but they are stealing resources from you and your system. So certainly are. But again, the bottom line is, it's when a computer is under the control of another computer. Okay, and when all the computers then, if they're talking to that same command and control server, then that makes them a part of a botnet. Botnets can get very large. You can have thousands, tens of thousands, hundreds of thousands of systems under control of a single botnet. Adware, those are just simply programs that delivers ad content in a way that's unexpected or unwanted. So you open a browser and you have ads in a page you never had ads before, or every time you open a browser you get 3 or 4 different pop-ups. Okay, that's an adware program. Keylogger is just that. It logs your keystrokes. Those can come in the form of an actual, malware. So Zeus is a keylogger. It can be USB. You can actually have someone insert keyloggers physically. So maybe in between your keyboard USB and your computer itself. Bottom line is, though, regardless of how you get a keylogger on your system, it's trying to record keystrokes and then allow someone else to later get that information. Sometimes the keystrokes are recorded and uploaded right away across the internet to whatever that command and control server is. Sometimes they're stored locally, and sometimes they may be stored on a USB file or USB drive, and you have to come back and physically get those. But however the method, what they do is record keystrokes. Okay, so that's malware. Moving into social engineering then. Again, a very broad topic, and there is a lot of different ways social engineering is accomplished. So we'll just look at some of the basics because we're just working on an introduction. So social engineering then at its core, at least to me, it's exploiting human nature, exploiting our willingness to typically trust people without necessarily having that trust proven, and also exploiting our willingness to help people. It's very rare well, I shouldn't say it's very rare, but oftentimes people want to be helpful, and so especially if they're in an environment like a call center, and you call them up and say, hey, I'm having a bad day, I just really need some help with getting my password reset to get into this website because something happened to my credit card. So whatever the case is, social engineer will be trying to elicit or trick that person because they want to help you out. If you're having a bad day, that's the last thing they want to do usually is to dogpile on it, and so they want to help you. So that's what social engineering is. It's just impersonation. It's phishing. It's representing yourself or trying to essentially trick someone into giving you information or giving them information that they shouldn't have. 2 big categories of that. Okay, impersonation. That can come in a variety of ways. Oftentimes tech support, IT departments, they'll be the victims of someone being impersonating. I'll pretend to be some, an employee or even a fictitious employee in a corporation, and I'll call the help desk, I'll call the IT department, and I'll try to get information. I'll try to get passwords sent to me, or I'll try to get things reset. Or maybe I'm simply just farming for information, IP ranges or locations of servers or anything. I'm just trying to get information that I can't find anywhere else. It can go in the reverse too. I could pretend I'm IT and I can try to get a hold of executives in a company or other employees and trick them into sending me information that I shouldn't have. If I can call up the president of the company and pretend like I'm IT and that his accounts, create some sort of a crisis that he needs to respond to immediately and get him to give me his username and password, that might be the quickest and easiest way to do it. And so that's why there is a lot of care needs to be taken into preventing social engineering. Well, it's not preventing but training, I guess, because there's no magic formula for preventing it. A lot of it falls on just a user awareness training and letting employees and other people that handle or have access to that critical information, let them know you have policies and procedures in place, and that they need to follow those. All right, phishing is another big category, and that simply is like sending out emails to a large number of people with some sort of false information and hoping that somebody will catch it, click on that link or execute that attachment, and trigger that malware, send you their credentials. Okay, oftentimes you'll see spam email and it'll have links in it, and the email will look legitimate. It'll look like it's coming from Wells Fargo or Citibank or some financial institution. Financial institutions are very popular because that has a big payoff if someone can get your information to log into one of your bank accounts. So they'll look legitimate, But if you actually inspect the link, the hyperlink in that message, you'll see that it's not taking you to citibank.com. Maybe it's taking you to citibank.biz or citibanks.biz or some domain name that if you don't actually, or if you're not really paying attention, it's not legit. It's not the actual organization that you think you're going to. You go to that, they follow that URL, they go to the malicious site. It's going to look identical, if not very similar to that original site. And then they can trick you into doing something. Oftentimes they're just going to want you to try to log in. They'll capture your username and password because now you've just tried to log in on their server, the bad guy's server. And once they've done that, then they're happy. They got what they're after. They can take that information and try to exploit that account or sell it or store it for later use, whatever they decide to do with it. Within phishing, then, there's just a couple categories I want to point out. The first and the third are really, I think, about the only ones. The second one, I actually couldn't even find an example for that one. Spear phishing, then, and that's just taking that whole concept of phishing, but targeting it at specific users. So, instead of sending out an email blast, pretending to be Citibank to 10 million people, of which I don't know what the numbers would be, but maybe not even half of them are actually Citibank customers, so they'll ignore it. I somehow come across a list of Citibank customers, and I send my phishing message out to just the Citibank customers. So I refine my phishing campaign down to a targeted set of users or subset of users. So that's how spear phishing is. Whaling, it's targeting the big fish, so wealthy individuals with money and resources. And then vishing is voice phishing. So, leaving a voicemail for someone and using social engineering to try to trick them into calling a number back or providing information or sending it somewhere. But the main exploitation comes in that you're leaving a voice message for that, your intended target. With SE, I kind of have a tough time pulling this one into social engineering, but it is still a very important security topic, and that's dumpster diving and tailgating. So tailgating, definitely, I'd say that's social engineering. Dumpster diving, okay, maybe not, it doesn't matter. Dumpster diving is important, and that is just jumping in a dumpster and trying to pull out information. Okay, so pen testers, that is oftentimes something that they'll do depending on the level of pen test that they're doing. They'll go on and they'll do some of that physical security. They'll look in dumpsters and any other garbage can, and they'll try to pull out information that can give them insight into the organization, names and emails and passwords and anything they can find. That's why it's important, and why a lot of organizations implement 100% shred policies. So it's important to be aware of what's going out in your trash, and that everybody understands to not put sensitive information in the trash. The last one is tailgating, and that's just simply trying to gain physical access to an organization by either following somebody in and bypassing whatever physical security mechanisms they have in place. Oftentimes you'll have card readers or RFID scanners, or some physical security that doesn't actually have a guard there checking IDs, and so they'll try to just piggyback in behind someone, or they will pretend that they've lost their ID card or they lost their RFID pin, or maybe they'll stand there with their hands full of boxes so that they can't actually open the door, and they'll wait for somebody to come along and help them out by holding the door open for them. So it's just trying to breach the premise, get inside access, physical access to an organization that they shouldn't have access to, by relying on another employee or someone with authorized access to allow them in. Okay, so that's all the terms and definitions I wanted to talk about. The last thing we'll look at is just a tool that you can find, and it goes through kind of some really neat social engineering. So there won't be a lab over this, and I won't ask maybe but 1 or 2 questions on a quiz, just some real high-level conceptual stuff. So you don't feel like you need to download this tool. If you want to, you're more than welcome to. It is a great tool, and it's a great thing to learn on, and it's a great thing to understand. It is heavily used in the industry, which is another reason why I wanted to bring it up. But again, don't feel like you have to. So it's the Social Engineer Toolkit. This is made by a guy called Dave Kennedy. He's a relatively big name in the security industry as a penetration tester, hacker, exploit writer. also the author of SET, so just be SET for short. Um, if you go to, so what am I on? I'm on trustedsec.com. I'll back up here so you can just see his website for his business. Go to Downloads, Social Engineer Toolkit, and if you scroll down a little bit, you'll see this. This is how you download it. Okay, so there is no like download package, there's no executable. You have to copy this command and actually run it from a command line. So Git, if you're familiar, it's just code, code versioning, code management software. I could talk to you about it for half a day if you wanted me to, and I'd really like to. I use Git on a daily basis as for a variety of things now, to include getting things from other people, getting software from other people. You don't need to know anything about it though, other than copy that code, copy that little snippet. Don't get the number 1. You want from Git to this last piece here, so that last /. Try that again. And if you want to go into your backtrack machine, then you can see right now I'm in Pentest Exploits. And if you go to Applications, Backtrack, Exploitation, Social Engineering Toolkit, Set. If you click on that, you'll see that it's not there. Okay, so I don't know the history behind it as far as its use on Backtrack. For some reason, it's not installed on here. You're also going to find that if you try to follow along here, there's some changes I had to make to actually get it to work. Your best bet is probably to just download Kali and run it inside of there. I guess I'm not even sure if it's in there. I'm just guessing that it is. If it's not, it's still, you can follow these steps, and I would do it probably with Kali. If you want to do it on Backtrack, if you're really interested in running the tool or playing around with it a little bit, and you can't get it to work, feel free to send me an email and I'll point you in the right direction. But again, for whatever reason, it's not there. And keep in mind, Backtrack is no longer supported. So you just might not have a good experience trying to run it on Backtrack. So inside, let's see, we'll go back to, we'll get rid of that because I don't really care about that terminal. I'm in Pentest Exploits, and we can see that there's no SET directory here. And that's where when we ran that last command, exploitation, social engineering, SET, you can see this is where it tried to run that command. Pentest exploits SET. SET, because it ends with a trailing /, that's looking in a directory. If you paste that command that we got from that website, you'll see git clone this address and then this value right here. If you hit enter, what that'll do is it'll download the code and it'll create this set directory. Okay, so I'll let that kind of work here while we go through it. I've already set it up, so we'll come back and I'll show you the last couple of commands that you have to do to get it to run. We're going to look at using set to do a website clone. Okay, so when we talked about phishing campaigns, I talked about oftentimes the bad guys can set up a site that looks very similar to a legitimate site, but it's not legitimate. And so they try to trick you into going to that site, submitting your sensitive information, your credentials, and then now they have that information. So we'll use set, and we'll go through a demo of that just to give you some idea of how you can use set for social engineering. I'm going to do a couple things here to get cleaned up. var www, so var www. This is the default directory for the web server, for our Apache web server. This is where we install DVWA. So if you're going to install this and you want it to run on the same machine that you have DVWA installed on, it might be easier to not do that. You don't have to delete everything in here. If you run rm star, that deletes everything, and so don't do this. Don't delete DVWA. We still need that. You have a couple different options. You can probably the easiest would be to make a copy of Backtrack, or again go to Kali, or send me an email and I'll tell you what to do. I'm going to clear it just to make it clear for this demo what we have going on. So there's nothing. I just did an ls command inside the www directory, and there was no results. Okay, so that means there's nothing inside that directory. You can also see with my terminal, I'm going to have a couple of tabs open. So I'll be flipping back and forth between them. The first one will be that directory here. The second one, and let me get out of here. Will be set, and then the third one, okay, well, now that that's done, I can just show you this, then we'll close it and get rid of it and get it out of the way. So this is what it'll look like after you've done a git clone. That just means you've copied all the code located at that website and put it into set. So now if we do an ls, you can see we have a set directory. So now we can change into set and list the contents. Whole bunch of stuff, but you can see there's a setup.py. And that's what you're going to want to run. So /setup.py, and you'll see here that it says to install setup.py space install. So that's actually the command you're going to run. Since I've already done it, I'm not going to do that. Do that, and it'll install set, and then it'll tell you when it's done how to run it. So that would be the install for you. Okay, so after that runs, clear this, you'll have SE Toolkit. Okay, and if you run the SE Toolkit, this is what you'll see. Information about the author, what version you're on, and then the menu. Okay, so a lot of different options here, and we're only going to talk about one. So social engineering attacks, number 1, enter. And then we have a bunch of options here. And we're going to look at the website attack vectors. So I'll enter a menu option of 2. And now you have these options here, and above it you have an explanation of what they are. Okay, we're just going to look at the credential harvester. So again, if you're interested in it, set up the tool and kind of explore these other options. If you do anything else, you can read through them and just kind of get an understanding or a feel for what set does. Credential harvester attack, that's 3. All right, so now we are at this point. Okay, so if you read along, essentially what we want to do is we want to create a clone of a website to use to trick the user into visiting and submitting their credentials. We're trying to harvest their credentials. With that, we have 3 options: use a template, use a cloner, or use a custom import. All right, custom import will just be custom options. Site cloner will be to set it to use any site you want. You just type in a URL and it'll create a copy of it. The templates, we're going to use that because there are already templates that have been built. Okay, so this doesn't, this requires a little less work because there's only 4 or 5 options. So I'll choose option 1, hit enter. All right, it says the IP address for the post back and harvester tab nabbing. So we're not doing anything with tab nabbing, don't worry about that. Harvester is the credential harvester. So where do we want to post back the information to? Remember we talked about kind of the beginning of the semester that client-server architecture, and that is you go to a website, type in your credentials, you submit that form. That's actually posting that information to the server. So that's what they're referring to here. In order to post, we need to tell this clone site that we're creating where it needs to post that information to. So on a Linux machine, if you type in ifconfig, you'll see here, this is our actual IP address. Okay, everything for us is a local IP. Okay, 192.168 will be the IP addresses we use. If I really truly was a bad guy and I really did want to do something like this, then I'd probably have a public IP address and I'd map it to a domain name. One of those domain names that is very close to the legitimate domain name, but it's not. It's something that I can actually purchase. So in this case, I just want to post back to myself. That's my actual IP address. It's like the loopback, 127.0.0.1. Hit enter, and now it'll ask us what template we want to use. I'm just going to use Google, so I'll hit number 2. And here you have some information. It's cloning the website, google.com, and starts Apache to make sure it's there. And now it's dumped all the files it needs into var www. So if we go back to that tab, do an ls, you'll see there's some information here. There's the index, there's the post file, and then there's this harvester file. So what this is, we can now open up our browser. Okay, and if I go to 127.0.0.1/index.html, it looks an awful lot like Google. All right, we know for a fact this is not, because look at the IP address I'm on. This is localhost. I'm on localhost. I'm on my own web server, but it looks almost identical, and most people wouldn't be able to tell the difference. In fact, it might even be identical. I couldn't say for sure. But that's the file. That's the file right there. Set made a copy of it, and now we can host it. People can get tricked into going to something like this. The problem is I control this page. I control it's on my server. And so if you submit your information, you're not submitting it to Google, you're submitting it to me. If you look back in that directory, then there's another file, a post file. And all that does is that helps build information on where to send this information. So when I submit the credentials, where do I post it to? In this case, we're just going to put it into this file. Okay, there's a text file in here. If we look at that text file, you can see it's empty. Now, one thing that I ran into, an issue that I ran into, is this doesn't actually work. And so I'm not going to go into, I'm going to go into the file itself, oops, and just make one modification. Ooh, I take that back. I think it is going to work. All right, so what I'm going to do now, this looks good. I'm going to minimize it. We'll just try to post back information. All right, so I'll hit F12. I'll open up the console using Firefox, and what we want to look for, yeah, network. So I'll type in user password and click sign in. Okay, there was a post. It posted to post.php, and it posted to that domain name. Now it did that, and I've got nothing else in my browser. You can see that I actually redirected to post.php. What's supposed to happen is that it then redirects you to google.com, so accounts.google.com, so that it would look completely transparent. You'd log in once, it wouldn't work, you'd go, that was weird. You'd maybe check the URL bar at that point in time, and you'd see that you were on accounts.google.com. It should have redirected us to a legitimate site. So again, I've had a couple little issues, but because I just wanted to give you a basic understanding, a basic demo of it, it's not a big deal. Again, I'm not expecting anybody to actually download this or run it. I just wanted to give you an idea. So it posted to, get rid of that file, don't worry about that. It posted to post.php. Okay, we saw that in the network activity tab here. And so what I'm hoping we'll see is some content in that text file. So here we can see that there is some information in our harvester text file. So if we take a look at that, here is all the information that was posted. And here's the stuff that I care about, user and password. So what I can do, what the bad guy can do with something like this, is they can take that form, and instead of having it just dumped to that text file on that server, they could have it posted to another server, or a whole variety of things. The important thing is that unless someone's paying attention, they might just look at this form, click login, submit their information, and now somebody that shouldn't have it has it. So this is just another way of combining multiple attacks, social engineering methods, to try to exploit users. So that's really all I wanted to cover. Again, okay, so just to kind of recap, lay out some broad definitions, some broad categories looking at malware, and then looking at social engineering. SET, Social Engineers Toolkit. I would encourage you at some point in time to take a look at the tool, to maybe download, try to get it set up, run through the menus, and just look at the different options it has. Dave spoke about SET at DEF CON, and if you're not familiar with any of those things, then Google all of them. But don't worry about actually getting it set up if you don't want to. Okay, there will be no lab over it. It's just a demo to provide, to give you some insight into how people kind of chain these social engineer attacks in order to actually exploit someone. So don't worry about that. If you do decide to set it up and it doesn't just run in Kali, you're not running Kali, you want to set it up and backtrack again, send me an email and I'll try to help you out and work you through it. But don't worry about it. So that's all I have today, and I will talk to you guys next time.